Good day, everyone. Today, I am going to discuss an important topic in physics, electric power. Electric power is part of our everyday life because almost everything we use today depends on electricity. Our lights, electric fans, refrigerators, televisions, chargers, and even computers all need electric power to work. Because of this, understanding electric power helps us understand how electrical devices function and how electricity is used safely and efficiently. Now, let us understand what is electric power. Electric power is the rate at which electrical energy is used or transferred in a circuit. In simple terms, it tells us how fast electricity is being used by a device or appliances. For example, a brighter light bulb usually uses more electric power than a dim bulb. Appliances that produce more heat, light, or motion generally consume more electrical power. For instance, an electric fan uses less power compared to an air conditioner. A phone charger uses less power compared to a refrigerator. This shows that different appliances consume different amount of electric power depending on their function. Before we fully understand electric power, we first need to understand three important concepts related to it. These are voltage, electric current, and resistance. First, let us talk about voltage. Voltage is the force that pushes electric charges through a wire. It is sometimes called electric pressure because it causes electricity to move in a circuit. Without voltage, electric charges cannot flow. Examples of sources of voltage are batteries and electrical outlets in our homes. Higher voltage can produce greater electric power because it pushes more electrical energy through the circuit. Next is electric current. Electric current is the flow of electric charges in a circuit. It tells us how much electricity is moving through the wire. Current is measured in amperes or amps. With more current flows in a circuit, more electrical energy is transferred. This means that appliances may work stronger or faster. For example, a stronger current can make a motor spin faster. It can also make a bulb shine brighter. The third concept is resistance. Resistance is the opposition to the flow of electric current. It slows down or limits the movement of electric charges in a circuit. Resistance is important because not all materials allow electricity to flow easily. Some materials resist the flow of electricity more than others. Resistance can also produce heat. This is why some appliances such as flat irons, rice cookers, become hot when electricity flows through them. Now that we understand voltage, current, and resistance, let us move to the formula for electric power. The main formula for electric power is P is equals to VI, where P stands for power, V stands for voltage, I stands for current. This formula tells us that electric power depends on both voltage and current. If voltage increases, power also increases. The same happens when current increases. There are also other formulas used in solving electric power problems. This formula is used when the values of current and resistance are known. This formula is used when voltage and resistance are given. These formulas helps us calculate the amount of electric power used in circuits and appliances. Next, let us talk about the unit of electric power. The standard unit of electric power is called watt, symbolized by the letter W. 1 watt is equals to 1 joules per second, means 1 watt is equal to 1 joule of energy used every second. Small appliances may use only a few watts, while larger appliances use hundreds or even thousands of watts. There are also larger units of electric power. The first is kilowatt, or kW. 1 kilowatt is equals to 1,000 watts. Kilowatts are commonly used for household appliances and machines. Another larger unit is megawatt or MW, which is equal to 1 million watts. Megawatts are used in industries and power plants. Now, let us discuss the two types of electric power. The first type of electric power is direct current or DC. In direct current, electricity flows in only one direction. The examples of devices that use DC power are the batteries, the power banks, flashlights, and mobile phones. The second type of electric power is alternating current, or AC. In alternating current, electricity changes direction repeatedly. This is the type of electricity used in our homes and buildings because it can travel long distances efficiently. Examples of appliances that use in AC are electric fans, refrigerators, air conditioners, and televisions. Electric power is very important in our daily lives. It is used in our homes, schools, hospitals, factories, transportation, and communication systems. Without electric power, many technologies and appliances would not function properly. However, even though electricity is useful, it can also be dangerous if not handled properly. Some electrical hazards include electric shock, overloading, and short circuits. That is why we should always follow safety precautions. Here are some important safety tips. Avoid touching exposed wires. Keep appliances away from water. Do not overload electrical outlets. Turn off appliances when not in use. There are also safety devices that protect electrical circuits. The first one is the fuse. A fuse melts when too much current flows in a circuit, preventing the damage. The second one is the circuit breaker. A circuit breaker automatically turns off electricity during overloads or short circuits. These devices help prevent electrical accidents and protect appliances. By understanding electric power, we can learn how electricity works, how energy is consumed, and how to use electricity safely and efficiently. Thank you everyone for listening, and see you to our next vlog.